an AI-generated post for your viewing pleasure. Breaking down the Kov algorithm, analyzing black box LM attacks. What if I told you that even the most advanced AI chatbots can be tricked into generating harmful responses in just a few queries? The Kov algorithm reveals alarming vulnerabilities in large language models, demonstrating that this cutting-edge technology may not be as safe or resilient as we thought. This is a must-watch for anyone interested in AI ethics, safety, and security. Before we dig deeper, let's set the scene a little. We're about to explore some complex ideas, but don't worry. I'll break it all down in a way that's easy to understand. Now, let's jump into the research. In today's digital age, we often turn to artificial intelligence to provide assistance, generate content, and even facilitate crucial decision-making processes. However, a recent study conducted by Robert J. Moss at Stanford University shakes our confidence in these systems. The research uncovers the vulnerabilities of large language models, highlighting that they can be manipulated into producing harmful or toxic content. This study is not just about technical jargon. It's deeply relevant to our everyday encounters with AI, provoking thought about whether we can trust these sophisticated models in sensitive situations. The paper delves into a newly devised algorithm called Kov, which aims to test the robustness of AI models against adversarial attacks by cleverly eliciting harmful responses. This is an essential task in understanding how these technologies can be improved to ensure greater safety and alignment with ethical standards. As we explore the details of Kov, it becomes vital to recognize the potential dangers that lurk if we fail to scrutinize these models properly. Now let's break down the key concepts that will help you understand what we'll be discussing. First off, when we talk about large language models, or LMS, we're referring to advanced AI systems designed to understand and generate human language. These models are trained on vast amounts of text data, enabling them to converse, answer questions, and even create content that mimics human writing. Another term you'll hear frequently is red teaming, which refers to the practice of stress testing these models to uncover any vulnerabilities. In this case, the Kov algorithm approaches this challenge by simulating various scenarios using a method called Monte Carlo tree search, or MCTs. This technique enables the algorithm to anticipate possible responses from the language models and strategize accordingly. By focusing on these elements, you'll gain a clearer view as we dissect how Kov exposes the weaknesses present in LMS. The introduction of log perplexity as a naturalistic loss term enhances the interpretability of prompt suffixes, hinting at broader applications for adversarial techniques in the realm of virtual agents. If adversarial suffix optimization can lead to more natural interactions in testing environments, this could translate into more effective methods for training dialogue systems and customer service bots that need to adhere to certain ethical guidelines without losing the fluidity of conversation. With that foundation laid out, let's take a closer look at the technical contributions of the Kov algorithm and what sets it apart in the realm of AI safety. At its core, the Kov algorithm takes an innovative approach to red teaming by treating the problem as a Markov decision process, MDP, with Monte Carlo tree search, MCTs. This lets Kov not just make single token-level changes to prompts, but intelligently navigate through possible responses with foresight. By utilizing log perplexity as a naturalistic loss term, Kov aims to craft more believable and natural-sounding suffixes, providing adversarial prompts that are not only effective, but also less mechanical. This results in responses that could more convincingly pass any defenses an LM might have in place. The Kov algorithm demonstrates the ability to successfully jailbreak models such as GPT 3.5, responding to harmful prompts effectively, but reveals more challenging interactions with newer models such as GPT-4. This indicator of increasing robustness asks the question, how safe are we as AI technology rapidly advances? The findings also highlight the changing game. The document draws attention to the pace at which newer models, especially GPT-4, are developed, asserting a need for ongoing scrutiny to keep up with advancements. However, it's crucial to consider some limitations inherent in the research. The paper suggests applying red teaming as a deliberate strategy for testing AI models, yet it may not translate effectively into practical scenarios. As these algorithms encounter the complexities of real-world systems, their performance could diminish, raising questions about the robustness of the Kov approach in diverse applications. Moreover, the inability of Kov to jailbreak advanced models, such as GPT-4, indicates that as language models continue to develop, the methodologies that test their integrity must also evolve. This poses a challenge. How can we ensure consistent safety and robustness in LMS as they grow more sophisticated? Additionally, the findings of the Kov research are based on a limited set of models, limiting the generalizability of results across various applications. Lastly, the ethical dimensions of the Kov algorithm cannot be overlooked. Although the research emphasizes eliciting harmful behaviors to promote alignment and safety, it raises troubling questions about possible misuse of the algorithmic findings. Without appropriate safeguards, the very techniques designed to enhance safety could be manipulated by individuals with harmful intentions. Such ethical considerations must be thoroughly examined to ensure responsible use of the proposed methods. Next, we'll discuss how these contributions fit into the wider research spectrum and what this means for the future of LM safety and AI accountability. What makes Kov stand out is its balance of adversarial prompt generation with an aligned approach. It not only seeks to exploit vulnerabilities but also proposes solutions to ethical prompts. By evaluating responses against established moderation metrics, it finds more effective ways to keep AI in check, highlighting the delicate balance between testing AI robustness and ensuring its ethical use. This paper comes at a crucial time as AI grows increasingly intertwined in our daily lives, necessitating a significant focus on the leakage of harmful behaviors through models. Kov raises a fundamental question. Can the development of LMS keep pace with methods that exploit their weaknesses? Moreover, the study emphasizes the collaboration between academics and industry, encouraging responsible disclosures of vulnerabilities found an essential dialogue for ethical AI development. If used properly, the Kov algorithm can significantly influence how we approach AI safety in engineering future models. The discussion on ethical guidelines, however, falls short. Without a rigorous ethical analysis, the potential for misuse remains unaddressed, which is particularly concerning given the impact misinformation or harmful narratives can have on society. Finally, the understanding that adversarial techniques can inform ethical development poses an opportunity to shift the narrative around AI safety. Integrating user feedback could create a more participatory approach, ensuring that models adhere to the expectations and moral standards of their users and society at large. The Kov algorithm and research of its kind show us that the technology we rely on can be improved, but comes with a demand for mindfulness regarding potential misuse. This combined focus on sophisticated testing and ethical guidelines can shepherd us towards a safer AI-integrated future. In summary, the Kov algorithm is not just a tool for generating harmful behaviors. It is an essential step toward understanding and improving the safety and alignment of large language models. However, it is imperative for future research to incorporate a more extensive exploration of the ethical and societal ramifications of these findings. As we explore the capabilities and ethical responsibilities of AI, wrestling with its vulnerabilities is a necessary part of the conversation. With Kov, we see the dual paths of adversarial engagement and ethical alignment converging, ultimately pushing us towards more secure AI systems. As we further embrace AI in our lives, ensuring its alignment with ethical standards is not just advisable, it's imperative. Thanks for tuning in. If you found this breakdown insightful, make sure to hit that subscribe button and give us a thumbs up. Let me know your thoughts in the comments below. How do you think we can improve the alignment of AI systems going forward? See you next time!